All right, welcome back, and now we're going to do a checkpoint. So again, I'm going to read it, try to solve it on your own, and then come back. It says a sailboat leaves a pier heading due west at 8 knots. After 15 minutes, the sailboat changes course to north 16 degrees west at 10 knots. Find the sailboat's bearing and distance from the pair after 12 minutes on this course. All right. Okay, so go ahead and pause and come back, see if we get the same answer. Okay, so we're going to go due north or due west, right? So it's going due west. So here's the starting point, and it's at 8 knots, due west at 8 knots. After 15 minutes, the sailboat changes course. So 8 knots. So 15 minutes is a quarter of an hour. So 8 nautical miles per hour. So after 15 minutes, it's gone 1/4 of the 8 nautical miles per hour. So 2 nautical miles. So right away, we know that this is 2 nautical miles. Okay, then it changes course 78.18 degrees west of north. So that means this angle here is 78.18 degrees right west of north. Oh, I'm sorry. I'm reading the wrong problem. Hold on. Let's do that again. Okay, so let's read that again. So a sailboat leaves the pier heading due west at 8 knots. After 15 minutes, it changes course. So that's where we get 2 nautical miles. And now it changes north 16 degrees west. Okay, so that means from north, it's 16 degrees west of north. So that's going to be like that. And so this is 16 degrees. Okay. And it's going at 10 knots. And then after it's on this course for 12 minutes. So after 12 minutes, it's here. So now if it's going, what? It's going 10 knots for 12 minutes. Oh, excuse me. 12 minutes is 1/5 of an hour. And so 1/5 at 1/5 of an hour at 10 knots which is 10 nautical miles per hour. So that would be 2 nautical miles. So that would be 2 nautical miles again. Okay, so these are supposed to be the same. I know they don't look the same, but anyway. Now, the question is, find the sailboat's bearing and distance from the pier after so here we go. So we want that distance. So we want D, and we want to find theta. Okay, so let's do this again. So we know that this is going to be 16 degrees from before, alternating interior angles, right, with a transversal and 2 parallel lines. And then here, this angle has to be complementary of this angle. So that's going to be 74 degrees. Okay, so all we have to do is, again, we're going to find this side and this side. Okay, so we're going to find L1 and L2. So L1, okay, let's do sine of 16 degrees. So sine of 16 degrees equals L1 over 2, right? So L1 equals 2 times sine of 16 degrees. And then sine of 74 degrees is going to be what? L2 over 2. So L2 is going to equal 2 times sine of 74 degrees. Okay. And then we're going to get this distance here, right, by adding L1 plus 2, right? So this, let's call this S, right? So S is going to equal what? L1 plus 2, which is going to be 2 sine of 16 degrees plus 2, right? And now to find theta prime, right? Let's call it theta prime. We're going to use tangent, right? So tangent of theta prime is equal to what? Opposite over adjacent, which is L2 over S, which is going to be what? L2 is what? 2 sine 74 degrees divided by S, which is going to be 2 times sine of 16 degrees plus 2, right? Which means if I take the arctangent of both sides, I'm going to get theta prime is equal to the tangent inverse of this whole thing. Right? And then all I have to do is subtract theta prime from 90, right? So theta equals 90 minus theta prime, and I got my theta. And then to find D, right, all I have to do to find D is use sine again. So it's going to be sine of theta prime, right, which I can get. So sine of theta prime is equal to L2 over D, which L2 we know is this over here. Okay, and now I'm not going to do the calculations because I don't have my calculator. I can do part of it on my calculator, but I can't do it all. But I've done all the work for you. You just have to plug it in, and that should give you the correct answer. So that's the way to do it. Again, if you have any questions, reach out to me. Let me know what you got. Talk to you later.